Okay, so this is some information, a slide set on C Sharp, the language we're going to use for this class, targeted at students, developers, who know Python. So I'm assuming you already have that grounding. So we're going to convert you guys into C Sharp developers. Okay, on the left, you'll see something in Python that I hope looks sort of familiar. Have you seen something like this before? This weird underscore name. It's terrible, but it's the Python way. So this says if you were to run this file, then this line, this if statement is true, and it calls main. So the equivalent way of doing this in C Sharp is with all this junk. So we would define a namespace, we would define a class. Typically it's called program, but it could be called something else, I think. And that program has a public static void main method that takes in an array of strings that's called args. And then this is the starting point for the program. So this is a lot of boilerplate. That is the starting point of a program. In newer versions of C Sharp, they actually eliminated the requirement to have this class and method, and you can just write some lines of code. I don't like this because to me it sort of removes some of the control. I don't know if I can embrace this new way. I'm sorry, I'm old and I'm stuck in my ways, and I kind of like the idea that C Sharp is/was, but it's is object-oriented through and through. So even to just create the simplest program, just a hello world, you have to define a class, and that class has a special method called main that runs automatically. It's the starting point. From that class that you make, you could call other instances of other classes that would also have to be structured as classes. I think if you do this, which they have some kind of weird word for it, like bare statements or something, that's B-A-R-E, not the. They're just adding all this other junk around it for you without telling you, is what the compiler does. Okay, that's enough on that. So the one big thing that you'll notice about C Sharp, if coming from Python, is that we use braces, not spaces. So the curly braces are what define blocks. It's not the tabs or the spaces. It's the braces, the curlies. Now, if you are unhinged, then you might not put any spaces in your C Sharp code. That would be really bad form. So we're still going to put spaces in so that it tells the reader, which is often you or future you, this stuff is inside this stuff, which is inside this stuff. You with me? So we're still going to space, and VS Code's going to do that for us. But the spacing doesn't have meaning. The braces say what the spaces are, and I do love this meme. Secondly, second big change that is normal in the C world, all C-based languages have this, is every line ends in a semicolon. Every line ends in a semicolon. An if statement doesn't, but every statement ends in a semicolon. Most languages do this. Python and JavaScript kind of don't. It's optional in JavaScript, but I do love this meme as well. You seen this meme? You see this dude? Love it. So, semicolon. And if you forget, it's okay. The compiler will have a cow and yell at you, and nothing will work. So you'll just need to do that if you want anything to run. These are the two symbols for comments in C Sharp. So if you want a single line comment, so you've got some code, you can do that. And // those are forward slashes. that's next to the shift button, we'll just comment out this one line. If you've got code, many lines of code, and you want to take out all of the lines of code, you can do /* and then // and it'll comment out this whole block of code. Python doesn't exactly have that, although sometimes we simulate it with 3 single quotes. You ever done that? This is the official comment operator, the 2 in C#. Single line, multi-line. Okay, did you guys ever talk about data types in Python? Like, they were there, but they weren't really necessarily slapping you in the face. They're going to slap you in the face in a C-based language, definitely in C#. So things like whether it's a number or a string or a Boolean, whether it's an object, those are like the main, integer or float in Python. In C#, as in most all languages that have data types define 2 things. I think this is important as a meta-level knowledge. They define what the possible values are. So if you're an integer, then you can only be 1, 2, 3, 4, 5, 6, -1, -2, -3. You could be all those numbers. If you're an integer, you cannot hold the value 3.75. It's just not, that's not allowed. It's not a legal value. Neither can you hold Jonathan or Jane. That doesn't make sense to store in an integer. In addition to the possible values, data types also define possible legal operations on that. So we can, if we have integers, have 2 integers. This is in C#. Int A is equal to 7, int B is equal to 2. Then I can have int C is equal to A minus B. And then C gets set to 5. Yeah? If A were instead a string, and this is John, and B is Jane, then minus doesn't make any sense between 2 strings. Now, it is the case, though, the plus operator, does have a meaning between 2 strings. It means concatenate them. But you'll notice that really has nothing to do with addition. Adding numbers is a completely different thing. It's just we've used that symbol to mean 2 different things depending on the data type. So this is your quick, brief introduction to data types. Like, this is the why behind it. When we say this variable is this data type, we're saying these are the possible legal values, these are the possible legal operations, and if you ever, future you, ever try to use an illegal value or an illegal operation, the compiler, which is the translator program, will yell at you, create a bunch of errors, and not let you run your code. But really, that's a good thing, because if it ran, what would it even do? It would just have to explode when it got to that line. You know what I mean? So we are now in the C# world. I guess that's maybe a big difference from Python. Going through a compilation process. So before we can run any code, the whole code has to pass the check that it's good or not. Whereas Python is generally interpreted, and when you run it in Python, it'll just run until it gets to the mistake and then throw out the error that happens having run everything up to that point. C# is picky, but picky can be good because it means we've definitely eliminated the obvious errors before we run the program. Now, it's still possible to do dumb stuff and have it break at runtime, but you've eliminated a class of errors. Okay, here are the data types, the main data types in C#. And you'll note that on this list, like everything that's in bold in the first column, these are keywords And anytime you create a variable in C#, you have to say what data type it is. Star. I'm going to come back and talk about an exception to that later. But generally, like maybe you saw in my writing up here, when I want to create a new variable, the first thing I'm going to do is think, what kind of data am I going to put in that variable? So if I know that I want some number, so this is a variable called number, I'm going to store a number in it that's an integer, and I've said up front, number must be this data type. And so the data type, and this is the variable name. And then we can put a semicolon there to end the line. So this is how we declare a variable. You've got to have data type and then some name. Later on in the program, we can then assign some value, 42, to this variable. I've got in the right column just some example values for each data type. So these are the main data types. These would be, I would call them like the primitive data types, the built-in data types that store the standard kinds of data. A long can hold a bigger range of integers. So it's still like an integer mathematically, but deep down, an integer only has 32 bits. So it can make 2 to the 32 patterns of ones and zeros, which is about, I think that's about 4 billion different patterns. Half of them are negative, half of them are positive. So each of these have like a range. Integers can store numbers between like negative 2 billion and positive 2 billion. Does that make sense? A long, on the other hand, is a 64-bit integer. So that means it can store 2 to the 64 different patterns of bits. And this is a gigantic number. This is much bigger. I don't know it off the top of my head. It's really big. So if you know you need really, really big integers that are still precise, you can use long. Floats are 32-bit fractional numbers, and doubles are 64-bit fractional numbers. On the whole, just always use doubles, okay? Just always use doubles. It's like floats don't exist. They're double because they're twice as long as a float, but on any modern computer, there's no reason to save that space. A decimal is like a double, only deep down in the computer, it's stored in base 10, in decimal, instead of in binary, in base 2. And this only really matters if you need to make sure there are never any rounding errors in a base 10 number. So this is largely, would only come up with financial transactions. Because doubles store numbers in a specific way, which I don't really want to talk about in this class, but they store them in binary in base 2, it's possible that you can do math and have some rounding errors that would actually cause you to like lose a penny. Banks aren't okay with that, right? You're not okay with that if it's your money. So sometimes we could use decimal. So like, that exists. The downside is if you use decimal, all the math on it will be like 10 times slower. A char, I say char. Some people probably say char, which is short for character. And I see how char is not in the word character, but that's how I say it in my mind. So you can say it however you want to. It's only a single character. Python, I don't think, has this. In C#, if you use single quotes, then you can only put in one character. And it is a different data type. It's a character data type. If you use double quotes, then it's a string, and we can have more than one character. However, we could still have the string A in double quotes or the character A in single quotes, and those would really be two different things because this string has other properties that a character doesn't have. In Python, you're used to having something that's just like a string. And lastly, there is a Boolean type, bool, that can only hold the values true or false. So these are the built-in data types. So this is our bread and butter. Anytime we declare a variable, it's going to be one of these types. Questions on this? Yo. That's correct. And nor can you. So the keywords for true and false must be lowercase in C#. They're uppercase in Python, right?
In Python.
You got to love languages. Every language is like, no. Let's do this different. I don't care the way everybody else has done it. Doing it different. Along those same lines, there's if a variable, maybe especially like a string in this case, has no value at all. It hasn't ever been set. There's a special value for that in every language, and it seems like every language uses a different word for that. What's the Python word that means this thing doesn't have any value? Joe, run into that? None. With a capital N? Remember none? No memory. You have no memory of that whatsoever. Okay, that's fine. So none essentially means there is this variable has never been set to a value. There's no memory address associated with this. So this is the Python way, and the C# way is lowercase n ULL, null. So null means there's no value for that. Unlike Python, where you just use a variable when you want one, you must declare variables in C# before you start using them. And this is the format for declaring a variable. Data type, which has got to be one of those from the list, space, variable name, semicolon. If you know the initial value, then you can say equals initial value. But even if you don't know the initial value, you must declare your variables before you use them. So this is how we do it. So in Python, we just declare and set the values we declare a variable by just assigning it a value, essentially in Python. In C#, before you can assign it a value, you've got to say data type, variable name, and then optionally give it a value. Okay? Python supports something called dynamic typing. I don't know if you ever did this. I kind of hope you didn't, because it's generally bad form. But Python would let you say x is equal to the string dog. And at that moment, x's data type in Python is a string. But then you could later assign x to 42, or 42 to x, and then it would change its data type to be an integer. You can't do that in C#. It has static data types. Once you've said that x is a string, you cannot assign 42 to it. That would be a compilation error. Your program won't even begin to run until you fix this, because that is not a legal value. Now, if you were to put in the string 42, which would be 42 in quotes, then that would be fine. That's allowed. But then you're not going to be able to treat it like a number and do math with it unless you convert it back to an integer explicitly. All right, you guys are familiar with lists from Python, just a way of having a list of things. It's hard for me to not use the word. A set of things that have an order. A set is technically something different. I'm trying to not use any of my words. But sets don't usually have order. And sets don't usually have duplicates mathematically. So an array is a set that has order and duplicates. Arrays are the built-in way of having essentially a list in C#. However, it's less powerful than a list, which might make you think, then I don't want it. But if it's less powerful, meaning you can't like add and remove, you can't change the size of it once it's been created. But the beauty of it is, because it's static, like you define, hey, give me a block. that's 100 things long. It's blank initially, but then you have 100 things that are going to be in memory in a block of 100 contiguous spots. It means they're very fast. There's not a lot of overhead. We know if you want to get to the 13th thing, just look at where the first thing is. Sorry, let me go this way. Look at the first thing and add 13 times the size. That's where the 13th thing is. We know exactly it's in that spot. So they're very efficient. So this would be a list in Python. This would be kind of the equivalent data structure of an array in C#. Yeah, Brian. They're indexed just the same way as in Python, yes. So they're easy to index. We can assign things to the spots, but we can't append and remove and change the length of the array. You're stuck with the size once you create it. We're going to see there are also lists in C#. It's probably like the next slide. But those are more powerful and equivalent to the lists that you're used to. So in that sense, maybe arrays are kind of a thing that Python doesn't expose to you. And the reason why we like them is because they're efficient. They're fast. So I know this is really cumbersome. I can never remember this syntax. But notice the data type here is an array, square brackets, says it's an array. What does the array have in it? It has integers. So this is an integer array. We could do the same thing by putting the square brackets. So if we said bool square bracket data, we're here saying this is an array, and what data type is each element in the array? It's Boolean. So that would be an array of trues and falses. Notice on the right side here, if you don't have initial values, you have to say, what is the initial size? Remember, we said it's statically, it's a static size, meaning when you create it, you have to tell it how big it is. And this is the way to do that. There's a new keyword, and then there's the integer keyword. There's a square bracket again, so that looks very much like this, but you put in some number here. It could be a variable that can be interpreted at that moment. But this would give us, let me just do it this way. So if we had this Boolean array of data, and we set it equal to a new, I can go to the next slide, a new bool 5, then we've just created a block index starting at 0, and it can hold trues and falses. And by default, C# will initialize every variable to its 0 value. So 0 is 0 for numbers, false is 0 for a bool, and strings would just be would be null. They would have no value. Is that all? And characters would be, I think characters would be 0 as well. Not the character 0, the value 0. Which is really a way of saying this is a null character. Okay, so these are arrays, and arrays, even deep down in memory, they look just like this. That is, they're contiguous. 0 comes one memory address before element 1, which comes 1 before 2. You see me about contiguous. They're all in a chunk. And if they're in a chunk, it's really fast to jump around in there because you know exactly where you're going to go. Since it's in a chunk, though, we might not be able to add a new thing at the end because what if there's, in memory, some other variable is here? Well, we can't grow into that because that's going to overlap with some other memory. That's not okay. So when we need to have dynamic lists, we use the list. Yeah. This one, this one.
That's the int numbers for
Mhm.
then you Do those happen?
Oh, sorry, this is showing you two completely different examples. Sorry about that. Thank you for asking. So, and you couldn't do both of these in the same program because you can't declare a new variable of the same name when this one already exists. But this int numbers here is if you happen to know what the initial values are, then we have just created, in this case, an array that is storing 1, 2, 4, 8, 16. It's 5 elements long, 1, 2, 3, because there are 5 elements in between these curlies. And it can never grow longer than 5. You can change the values later on in the program to other integers, but you can't make them longer. To me, this is weird, and I'm sure there's a reason they did this, but it feels weird that in this one case, and only this case, you use curlies to represent an array when it's the initial values of the array. But generally, arrays are going to be used square bracket. So later on, once we've done this, we can say bool b is equal to data at, 2. And data at 2, square bracket 2, is saying, give me this value, which is the 1 false, and store it in b. Okay, so if we want to have more powerful arrays, really they're more like lists in Python, then we want to use what's called a generic list. In C#, anything that has these angle brackets, you see the angle brackets around the T, that's called generic. And the beauty of the generic is we've said we're able to define this thing that's a list operates the same way, whether it's storing a list of integers or a list of doubles or a list of characters or a list of students, some object that you've written yourself, you can have a list of them. What is it that a list lets you do? A list lets you add to the end. It lets you remove. It lets you look up. It lets you search through the list. All the kinds of standard operations that you've ever done on a list, this list will do. And you can do it with any data type, so it's still going to be strongly typed. That is, you can only store one kind of object, one kind of thing within the list. And the way that C# makes you do that is with this generic parameter. Let me see if I've got an example here. Yes. So when you're appending and removing, which is actually letting the list grow and shrink in C#, if you want to dynamically grow and shrink a list, then you need to use a list. Notice this list is capitalized L, and in square bracket, or not, in angle brackets, less than, greater than, which is in the name of the data type. So I mean, this is the name of the data type. This is a list of integers. You can only store integers in this list. You can't put in Boolean values. Only integers. Okay. This is the way that we create a new object. This is kind of the first object that we've seen. So when we create a new object in C#, we have to use the keyword new. I guess the arrays were technically objects too. After the keyword new, we put the data type of the thing that we're making and parentheses. In this specific case, I had some initial values that I wanted to go into the array of numbers, the list of numbers, and I had stored them in an array called nums. So you remember, arrays are the really dumb, simple lists, and lists are the full-fledged, powerful, dynamic lists. What I want you to see over here is that we have the keyword new, we have the data type. What's the data type? It's a list of integers. How did I know that? Because that's what I wrote right here as the data type of numbers. So this is the only constructor that I can call. A constructor is a function that runs to construct an object of a class. So this is, we're calling a constructor of the list data type. Microsoft wrote that class, not us, but we're calling their constructor. you can see after this, once we've set up numbers, we can do the kinds of operations that you're used to. In C#, it's called add and remove instead of append and remove. And in the C# convention, which you'll see Microsoft follow and we're going to follow, method names, that is operations in a class, methods, should always be uppercase. In Python, the convention is lowercase. In Python, the convention is to use underscores when you have multiple words in a name. They call that, don't they call that snake case? What do you call it? Do you call it snake case? Camel case is what we're going to use. So like, if we were naming a method in Python, we would, I think, call it like add to end. Is this the convention y'all used? Yes? I think this is called snake case because it's like the snake ate a thing, but then it's like skinny where the thing isn't. But in C#, we would say add to end, where they call this camel case. Capitalized letters, and there's no underscores. That's just a convention. Like, you could name stuff like this in C# and vice versa, but it would make you look like you don't know what you're doing because it's not following the conventions of the language. Garrett, you have thoughts?
Last year, I was always
Those people at the Python parties were really laughing at you, I'm sure. I know you went to a lot of those Python parties. Since we're here, the other case that I'm aware of is, I think maybe JavaScript uses this. To put dashes in between. And no joke, I believe they call this kebab case. It's like a kebab that you put a thing through. But don't write a kebab case unless you're in a language that's the convention for. Okay. Ugh. Oh, I'm so sorry. What is even happening here? That unfortunate line break. Ugh. Okay. Hideous. Okay. Y'all got to grow up learning Python, and you use dictionaries, right? You remember the dictionary? You probably, like, it's cool because you got to use it. It's really powerful. To me, it's a very powerful data structure. And it's just like a built-in thing that everybody uses in Python. It, to me, feels more advanced than that in C# and other languages. Here's the equivalent way. Remember, in C#, we have to tell the data types up front. So a dictionary is also generic. We know it's generic because it has these angle brackets. And in order to create a dictionary where we have keys that look up some value, we have to say, what's the type of the keys? That's what the K stands for. And what's the type of the values? V. So let's see what I did here. Okay. So in Python, you could just say club wins. And we've got XBX:3, EP:8, PKA:11. The stuff that I have in this first column, is that the key or the value? Hang on, let me, just from the structural standpoint, this XBX, EP, PKA, is that the key or the value? It's the key? You sure? Anybody think it's the value? No one thinks it's the value. Would you wager 5 push-ups on it? You would? So if you're wrong, you got to do 5 push-ups, like right now. Okay, you're right. What's that? I never wagered that.
You were the one who made the bet.
No, you were the one who didn't make the bet. I don't. Um, I mean, I wasn't wrong. Also, so this is the key, and these are the values associated with the key. So the first thing that we put in is like the way we would look up the other bit of data, which we are calling the value. I mean, you know why? It's called a dictionary because a long time ago, like when I was a kid in the 1980s, we had these books. We had like, books. They're like these printed out dead tree with writing on them things. And I think we had dictionaries for the whole class. Y'all didn't have this in your elementary schools, did you? So there was like a bookshelf, and I'm pretty sure we had enough dictionaries for the whole class. These little kid dictionaries, they were books, and you could actually get them. They're organized in alphabetical order, and you can look up a word and see its definition. Did you? Glossaries. Okay, yeah. Yeah, I'm talking about a normal dictionary. I don't know if y'all still knew what those were. Um, you got it? Yeah. So you did have those or you didn't? Or you just have one? I was trying to be like sarcastic for my oldness, but I do suspect that down the street at Chester County, like at East Chester, they do not have 25 kid dictionaries anymore where everybody can go over and look up a word, which like we had in my room in the 80s. So that's where this word comes from, where in that sense, the word would be the key and the definition would be the value. We often use dictionaries to do other kinds of lookup that isn't the meaning of a thing, but some other associated information. This is much more verbose. You guys know the word verbose? Or do we need to look that up in a dictionary? We need to look it up. What do you think it means based on context clues? Okay. Define verbose.
No, I mean like.
Can you use it in a sentence?
This is my kids. Verbose is a word that you can look up in the dictionary. I just use it in a sentence. You see, that doesn't give much context clues. It's like very wordy. So to me, like you'll see here, you're probably going to have to type more stuff in C# to get the job done. But on the other hand, Copilot, IntelliSense is probably going to help you once you start getting along the way, so you don't have to type as much. So if we want to add 3 entries into the dictionary, this is the equivalent code here. So we've got to say this dictionary. Notice the dictionary when we set it up, it's a dictionary, and we have to say the keys. The first parameter is the key parameter, is a string data type. The value is an integer. We're going to call the constructor of a dictionary, which is new. The data type, which is having to repeat this long thing again, which is annoying. I'll show you a shortcut on that later. And parentheses calls the constructor, where the constructor is the function, the special function that's built into every class that creates an object of that type. It kind of sets it up so that you have an empty one. And then we can call .add, the add method 3 times, passing in key, comma value, key, comma value. Yeah.
The dictionary constructor there is on 2 different.
Yes.
Does that mean it's all one, or would breaking it up into 2 lines?
Good question. I didn't realize. I forgot who I was talking to. So in Python, this would like break everything. In C#, the compiler doesn't care about lines. A logical line is until you get to a semicolon. So if you want to just wrap something in the next line, it's equivalent. So yeah, so really I just line wrapped this because there wasn't enough space. But that would break Python. But in C#, this is all one line logically. Good question. Didn't mean to be tricksy there. Yeah. So if you want to be evil, you could write, like we could squish all this down to one line, and the compiler wouldn't care. No, not at all. Because on the whole, also, once the compiler converts it to the low-level code, it doesn't bring over spaces, right? It doesn't need spaces. That's just for your readability. And also, if you compile something, when you actually compile something, it'll also strip out all your comments because your comments aren't needed when the code is running. Okay, so many questions. Awesome. No, don't apologize. You're good. I would say most of the time, yes, but it depends on lots of what you're doing and how you've done it. You can make something run badly in any language, but because C# is compiled, means that you do all that translation up front, whereas typically Python compiles just in time or it's interpreted. That's slower. But I don't know, they're always doing more and more work so that things actually are typically getting faster. But on the whole, like I would say, test it and see for your particular problem. I know I saw Ryan's hand.
What if you put?
No, because the thing that makes the word dictionary a special keyword is that it is there can't be spaces in between letters of an identifier. So the legal letters to put in an identifier are letters, numbers, underscore. I think that's it. And you can't start with a number. I don't think you can put a dash either. So actually, yeah, kebab case wouldn't, I think that would be illegal in C#. Tristan? Good question. So garbage collection is the fancy word that means how does the code clean up after itself, if at all. And C# is a language that has garbage collection, which means as a part of your program running in the .NET framework, remember that stuff we installed, the .NET runtime? There's another program running that cleans up memory that's not being used anymore, and that's really outside your control. So it's nice because you don't have to clean up after yourself. When you stop using memory, you stop using a variable, you don't have to jump through any hoops to say, clean this code up, clean this memory up. You can reuse it. There's another program that runs. The downside to garbage collection is you're not in control of when garbage collection runs, and it might actually slow down the running of your code. It's a little unpredictable if you're really, really hardcore about performance and knowing exactly how something's going to run. So a language like C++ does not have garbage collection. We would call C# like a memory managed language because there's a system that's managing the memory. In C++, you have to clean up after yourself. And if you don't clean up after yourself, then you have a memory leak, where your program, as it runs longer and longer, it just consumes more and more memory, and it never gives the memory back. Good question. I should have mentioned that on the front end. Okay, so we have data types, and we've seen even the two kind of special data types that Python has, lists and dictionaries, and C# has equivalent ones. And the main difference is you got to be explicit about the data types that you put into a list or a dictionary, and you do that using what C# calls generics, which is to say the list is generic, it can operate on any data type. The dictionary is generic, it can operate on keys and values of any data type, but you got to tell it the data types up front. How do you control the flow of code in C#? How do you control the flow of code? It's primarily the same statement that every language uses, mercifully, which is if. So if you have two options, then you're going to use an if statement. If some condition, then run this code. Otherwise, run this code. So that's one of the essential things that any programming language has to give you is the ability to sometimes run code, but not all the time. C# also has a switch statement, which it inherits from C. C++. A switch statement, which I'll show you in a second, is a way of saying if you have like 5 options and you know what the 5 options are, instead of writing if, else, if, else, if, else, if, else, if, else 5 times, you can use a switch statement and say, hey, switch, look at this value. If it's this, do this. If it's this, do this, this. All right, so let me show you an example. First, if, else. There is no else statement. No, there is an else statement. There is no, like the colons. No colons. And we're going to denote blocks with curlies. So these would be equivalent logic in the 2 languages. And I think that's pretty readable. Yeah? So we've got curlies instead of spaces and colons. And we still have if and else. Nope. The indent can look however you want it to. But if you don't want to anger your team, you would typically put this curly here and here and tab in. Or the other style that you'll see is they'll put the opening curly on this line to kind of save a line. Does that make sense? So like, here, let me just, oops. You'll see that. So, yeah. There's a meme that I see recurrently, which is you can do it this way. Oops. You can do it this way or the other way. What you should never do is do it this way. To make it almost like Python, yeah. Don't do that. So the meme has gone to great length, and they have a whole block, and all of the curlies are over here on the right side. I think it's hilarious. Don't do that. Yep. Mm-hmm. Right. So really, it's as if you can almost imagine this is one line to the compiler. And you could write code like this, and occasionally you'll see people do it this way. I guess I should teach you this. If you just have one statement in an if statement, you don't have to have curlies. You could write it like this. And some people would then write it, hang on. You could write it like this, and that would be equivalent. Don't do this. Okay, the reason is because if you were to, can I get rid of this for a second? If you write it like this is legal. This is what you want to do. Y equals 9 only gets executed if this condition is true. Later on, you'll come back and be like, oh yeah, actually, I also want to set z equal to 10 in that case. And you'll tab it over, and it looks reasonable, yeah? But to the compiler, that is not what that means. Even though you indented it this way, indents don't matter. If statements, if you use this implicit no curlies, it only includes the next statement. So really, that is what this statement is. Y is equal to 9, but every time z will be set to 10, regardless of x equals 4. Does that make sense? So don't do that. I think that it's better practice to just put the curlies in, even if it seems unnecessary because you got one thing, and later on you might just, you'll be in a better spot later on. Okay. Sometimes you get code like this. I don't know if you've ever had Python code like this. If, elif, 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 elif. Remember this? It's got to be a situation where there kind of are like, it's a multiple choice control flow situation, and you kind of know these are the different options. You could write it like this in C#, so an if and an else is enough to get the job done. But it would probably be cleaner and more I don't know, more C-sharpy to do something like this, where you switch on some value and then check the case. On some of these, you may actually have to have a break statement to make sure. I think it will have to have a break statement. So this is actually an error. It'd be tough to fit it all. After this to say, hey, when you've done case 1, break out of this and don't do case 2, 3, 4, 5. Okay. Here's maybe the thing that Python programmers seem to dislike the most. How do we do Boolean expressions, the Boolean operations of and, or, and not? Is this thing and this thing true? In C#, that's ampersand, ampersand. If we want to say or, is x equal to 4 equal to 4, or y equal to 5? 2 bars. The bar is above the enter button on your keyboard. You see that? I think you have to have shift, otherwise you get a backslash. And then not is an exclamation point. So exclamation point means not. If you want to reverse a false to a true or true to a false, use an exclamation point. So these guys, so I should have had an example here. This is how we do and, or, and not, these symbols. I respect that Python shows very readable words, but real programmers for the past 50 years have used these symbols to mean these things. So catch up. Okay. The last thing that you have to do programming is the ability to repeat code, repetition statements. And these are 4 constructs for doing repetition in C#. You don't need 4. They're syntactic sugar just to make your life easier so that you don't have to write as much code in different situations. Let's take a look at those. The while loop looks almost the same. This is the way you do it in Python. In C#, you see the main difference is no semicolon and parentheses are around the condition. So we're saying while x is greater than 0, we write x to the, this is how you would write to the console, and we increment x. This also kind of looks like an infinite loop. So, oops, because as x gets bigger and bigger, it's going to keep being greater than 0. Yeah? But that's a while loop. So it's the same as Python. We good here? One thing that C# adds that I don't think Python has, last time I checked, is a do while loop. It's still a while loop. It's just that you do the check at the end of the loop instead of the beginning. So you're saying do this block of code while this condition is true. So essentially, you could do that in Python by just saying do the loop once. You must do it once. You can never do it 0 times. A while loop, you could do it 0 times if the condition's false to begin with. A do while loop will always happen once. You do the check, and then you might do it again. So you see how this is just syntactic sugar. We could do this here in Python. It's the same thing logically. But here we wrote less code. So those are the 2 loops that are based on a condition that's checked either at the beginning of the loop or the end of the loop. So you call those a pretest and a post-test loop. The other kind of statement that does repetition is a for loop. And this for loop that I'm going to show you right now is the most powerful kind of for loop. If you've ever written something like this in Python where you have for I in range, we're using the range function to get a sequence, right, of 0 through 9. You would do something equivalent in C# like this. So this part is maybe a little bit dense, but this is how for loops have worked in C for a long time. So there's a for statement, and this for statement has 3 things. with semicolons in them. This first spot, this first like clause, in this case, int I equals 0, is what happens at the beginning of the loop. So this is at the beginning. So it is as if we've declared a new variable I and we've set it equal to 0. Yeah? All right, so we now have an I. This I, though, only exists, it's only alive within the scope of this for loop. The second thing here is the condition. So this is the condition for which the loop will keep repeating. So we're saying, essentially, while I is less than 10, then we're going to stay in the loop. If this condition ever becomes false, then we will stop repeating the loop. This is checked at the beginning of each loop. So int I equals 0, is 0 less than 10? Yeah. So we're going to do whatever's in the loop, which would just be printing out 0. The last statement here, the I++, is at the end of the loop. So this line is executed every time at the very last statement of the loop. So I++ means I equals I plus 1. Is this new to y'all? You can't do plus plus in Python? Or you can. Okay, so I++ in C# is equivalent to I plus equals 1. Oh yeah, sorry. Which is equivalent to I equals I plus 1. It's really hard for me to not semicolon. But this shorthand, because it's so common to increment a number, this is the C way of incrementing by 1. Maybe you can contribute that idea for the next version of C#. I think this is actually why C++ is called C++, is because they were trying to say it's like 1 better, but it's also like a statement in the language. Don't say C+. That's nothing. That's something that, don't say C+. Yeah, C++. No, C+ is nothing. C++ is a language. There's got to be 2 pluses. If you say 1 plus, there's C and there's C++. C. False. C+ is a way for you to demonstrate your ignorance of programming languages. Yeah? So don't do that. Don't say it. I guess you could have a C++++, and that would be a legal statement that would add to. But don't code like that. That's terrible. Okay, so this is what I was just saying. There's a start clause, a stop clause, and a step clause. That is a weird sentence to say. And there can be one or more statements in the for loop that repeat. And what I want to say here is you'll often see this in what we saw in the previous slide where you have like int I equals 0, I is less than whatever your maximum thing is, and then I++ is incrementing. So you go from 0 up to 100, and as soon as you hit 100, then you'd stop. But this same structure will let you go backwards as well. So if you want to start with the big number, if I is equal to 100 initially, and your stop clause is I is greater than or equal to 0, you're saying as long as you got a positive number, we're going to keep doing this. And on each increment, we decrement I by 5. There is minus equals. I think Python lets you do all that, doesn't it? Yeah, so you can, there is actually an I minus minus, or a minus minus, but I don't see that used as much. But that would just be 1. But you can star equals or divide equals as well. Yes. Yeah. This is a legal C# statement, you can just skip all three things and say for semicolon, semicolon, and it'll just run forever because there's no way to get out of that. And you'll actually see this used occasionally. If you were in something like a server, where a server, like a web server, just runs the same code over and over again. Or like a game loop, if you're making a game that's just always updating the stats of the game. And maybe the only way to get out is if you press C or Q or something, and then this could break out of this loop. All right, so this last loop that I want to introduce you to is most like a Python for. Python makes it easy to say for some variable you just made up in some collection. Are you familiar with this syntax? It's a pretty easy way to just iterate over everything in a collection. So same for C#. Anything that's like a collection is technically iteratable, which should be lists and arrays and dictionaries and lots of other things. You would say for each. So in this case, they actually make you use a different keyword for each to get this. The for each needs parentheses, and in the parentheses, you would do a similar thing about data type of the variable that you want, I, still the keyword in, and then the collection variable. And so this will then repeat as many times as there are things in that collection. So generally, if you have something that's like a collection, you're going to use something like this, where basically you know how many times you need to do the thing. You need to do this operation as many times as there are things in the list. So you're going to use a for or for each in that case. If you don't know how many times something needs to run, then you're going to use a while loop or a do while. Okay. Now this is the last thing. You kind of had this in Python, but it seemed more implicit. In C#, we explicitly state this is the area, this is the set of files in which names have to be unique, kind of the world in which you live. So even in this classroom, Caleb was bothered that there were two Calebs, and because it would be confusing. If I say Caleb, we don't know who we're talking about. So in this namespace, you had to have a different name so that there wouldn't be a conflict in that name. As we write our code, we can make it so that code in different files lives in the same namespace. So that would almost be if we could say that room also has the same namespace as ours. That would mean there couldn't be any Caleb's in there, but it could also mean if I say the word, I don't know, do you all know any of those guys' names? Okay, well, if I said the word Lisa, Lisa is a legal name that exists in the big namespace of both rooms because there is someone named Lisa in that room. Whereas if this is our namespace, there's no Lisa. If we code with the variable name Lisa, we're going to say name not found. We have no idea what that is because there's no Lisas in that room, in this room. So there's two ways of defining namespaces, but generally you're going to say namespace and then some name. And this is defining what your world is, and therefore anything that's in the same namespace as you can get to by just like almost calling it by its first name. If it's in a completely different namespace, then you have to say import that namespace, and then, which is like importing a module in Python. And then whenever you use it, you might or might not, depending on how you imported it, have to say other namespace dot name. So yeah, so import sys. Did you ever do like importing some other module so you can get to its functions? In C#, we say using name of other module semicolon. Okay, this is an excellent amount of stuff to get through today. The next thing I'm going to assign for between now and Tuesday, would y'all rather watch videos or read the Xi book?
Watch videos.
Does it? Yes? Okay, if you especially would rather do the Xi book up for basic C#, let me know, and I might be willing to swap it out. But I've got some nice videos of people from Microsoft teaching C#. I'm confident they're like 1.5xable, 2xable, but I would really like for you to get more and more perspective on C# so that you can feel comfortable in this language that I'm about to give you a lab in. And I know it's hard, or it's going to be a practice exercise, but we just have to struggle with it so that we can get comfortable with it. Okay? So be on the lookout for those videos, and I'll plan to have a practice exercise to give to you on Thursday. All right? Y'all take good care.